Hey everyone, welcome to the online lecture for today. My main goal is to give you help for the Lego project and mostly to help you avoid some problems. So we have 5 parts that I'm going to go over today. First part that I want to talk about is some project realities. This project is significant and it is difficult. It is going to push you to your limits. You need to get ready for that and you need to do everything you can to put yourself in a position to succeed. Let me be more straightforward with you about this and be specific. Don't do things that are going to make it harder for you. So here are some tips that I have to keep on the straight and narrow, so to speak. Item number 1, make sure you read the project deliverables. This has important information about what you should be doing. If you don't understand the target, you're very unlikely to hit it. Item number 2, read the body of the chapter. There's all kinds of important things in here, tips that will help you. That will help you do a great job. If you don't look at those tips, you're basically choosing to do the project without any help, which is going to make it harder for you. All right, now let's talk about the 2x4 Lego brick. This is the 2x4 Lego brick. You need to model the 2x4 Lego brick, but do not do it in isolation of how you think you will use that model in the design table. For example, we grab these pieces. This 2x4 Lego brick needs to become this longer brick, which is a 2x6, okay? And you need to be thinking about how this gets parameterized, so by changing just a few numbers, you get this thing. Likewise, you need to be figuring out how you can take a 2x4 Lego brick, let's say, and turn it into a plate, which is a thinner version of a brick. You also need to be thinking about how those 2x4 Lego bricks can become tiles. Tiles are those things that have no studs on the top. And then frankly, you want to think about all different versions of this. Large plates that have more than 2x4 studs. You want to make sure you can do odd number, even number of studs. Then you also have another design table that you're going to create. And that other design table is for the 1x(x)s. It is possible, of course, to do a design table with 2x-somethings and 1x-somethings all in the same design table. It just requires a little bit of additional Excel logic, and I prefer to not have you spend time on that right now. So easy way to do this is set of design tables for the 2x2 and larger, and then a design table for the 1x's. Okay, next important thing for you to do is to make sure you pay close attention to the deadlines. Go into Learning Suite and make sure you understand what's going on. There's a few things I want to point out right now. Number 1, you have a little bit less than 2 weeks to work on this project. Therefore, I highly recommend that you get the design tables done and all the parts ready for your assembly within just 2 or 3 or maybe at the most 4 days after the project has begun. So the project began on Wednesday. That means by the end of the first weekend or before the end of the first weekend, you really should be full mode in working on the assembly. That will give you 1 week to work on the assembly, and I believe you can do it in 1 week. But if you spend too much time trying to create these parts or work through your design tables, you're not going to have enough time for the assembly. So pay close attention to the deadlines. Schedule your time and be a good time manager. You might not believe this right now, but I just want to tell you that there's a couple things going on in any design project, and one of them is to learn to manage your time. All right, now this becomes extra difficult with this next point that I want to tell you. And this next point is that this is an open-ended design project. And because it's an open-ended design project, it can be very difficult for you to know when you're done. That's how all open-ended design projects are, because you can always make it better. You have to take control of the project and not let it control you. And one way to do that is to limit the amount of time you spend on each of the activities. I've asked you to sketch the 2x4 Lego brick, and I've given you a time limit for that. Don't spend any more time than that. You can't afford to spend any more time than that. You also can't afford to spend an entire week on design tables. You can only spend a couple of days on design tables at most. That will give you a whole week to think through your assembly, get your assembly worked up, And then don't forget, there is also a PDF deliverable, which is a design package, which is going to take a little bit of time to compile everything together and make sure you have a couple of hours near the end to do that. All right, and the last project reality that I want to talk about is that you're probably thinking too large about this project. You need to make sure you scope this well. So whatever building you're thinking of right now to do for your Lego project, you need to think of a few other buildings, 5 or 6 other buildings that are simpler, and then choose one of those simpler buildings. Or take the building you're thinking of right now and just scale down everything you're thinking about relative to it so that you have less number of parts to deal with, less details that you're trying to capture, but you're trying to do a superb, fantastic job on a smaller scope. That's going to be really hard to do, but I just want to encourage you to do that because the bigger your scope, kind of the bigger mess you're going to have on your hands. Sorry to say it that way. Okay, all right, those were the realities for the project that I wanted to talk about. Time for us to talk about part number 2, which is the Lego unit. Now, it's really important for you to know that in the project deliverables, when it's time for you to create the 2x4 Lego brick, you are being asked to create this in a thing that is called the Lego unit. The Lego unit is neither in millimeters nor is it in inches. It is its own thing, and it is called the Lego unit. And this image that you can see in figure 6.7 is listed out completely in Lego units. So the width of this 2x2 Lego Lego plate that you see in this figure 6.7 is 40 Lego units long. It's not 40 millimeters, it's not 40 inches, it's not 40 feet or anything like that. But of course, in SolidWorks, there is no Lego unit. We only have the options of millimeters or inches, basically. So you're going to model the entire thing in millimeters, as if the 40 was 40 millimeters, even though we're going to know in our heads that those are actually 40 Lego units. And then later, in the design table, you will scale that part from 40 Lego units to however many millimeters 40 Lego units actually is. So make sure you read the note that's at the bottom of figure 6.7. This will help you from doing the wrong thing. All right, how are we going to get from Lego unit all the way over to millimeters? Well, that's easy. I'm going to take my 2x2 Lego brick, and I'm going to pull out my calipers. Let me get my calipers. You're going to pull out your calipers that you needed to buy for the class. If you thought you didn't need them for the class, you do need them for the class. And the bottom line is that you need them in this project and the next project and the next project and the next project. So I'm going to get out my digital calipers. I'm going to measure the width of that 2x4 Lego brick. And what is that going to do? I'm going to use the common mathematical approach of similar ratios to know that this number I'm looking at here over 40 is the scale factor for me to go back and forth between Lego units and actual millimeters. So what are you going to do? You're going to make a design table, which we'll talk about in a minute. You're going to make a design table. Let me go to the next slide here. You're going to make in your design table a scale factor, and that is going to transition all of your initial parameter values that were done in Lego units to millimeters. And then after you've made that transition, every other part in your design table will be in millimeters. So you can see that in this example design table that's in figure 6.13. At the very top, we have the default brick, and we can see that the length of a default 2x4 brick will be twice as long as this one. And so that means that instead of being 40 units long, it will be 80 units long. And you can see that we have 80 units in length for one of our parameters in there on this row number 3 in figure 6.13. And we call that the default version. Right underneath that, you see the 2x4 white brick LU, meaning Lego units. Those also have an 80 by them. And then underneath that, we have gotten to ourselves of being in millimeters. Now, don't be confused. It's not 32 millimeters. It's just that this particular figure is not showing the decimal, the parts that are less than an integer. So it's not 32 evenly as an integer. It's 32 point something. And how are you going to know what that is? We are all going to measure the Lego bricks that we have. And we are going to take a class average. And that class average is going to be the scale factor that you use in your design table to go from Lego unit to millimeters. If you don't know what I'm talking about, please connect up with the TAs. Please connect up with me before you jump very deeply into modeling anything, because you want to make sure you're doing it in the right units. Okay. Next thing that we want to talk about here is if you're not sure how to use your digital calipers, go to the BYU Design Review, hit the little search button, type the word caliper. You do that, you're going to find this article, Getting the Most Out of Digital Calipers. And that will help you know how to use your digital caliper correctly and sufficiently to do what needs to be done for this project. All right, next thing I want to talk about here is the Lego parts that you have available to you. All of these Lego parts are available to you, plus a few others that I happen to notice were missing from this, and those are roof tiles. And so I will make sure I get those to you. But you cannot use parts that are not in this set, except for the Lego roof tiles that I'm going to give you, which are missing from this list, and anything you can create from your design table. Anything that you can create from your design table is free game. That's the benefit of you having created a design table that you get to use. So to be straightforward about how those parts are going to be made in your design table, we need to think now about part 3, which is to think about the advanced design table. You did some simple design tables when you did the screws, and if you followed along with the shaft example, those are simple. They're simple because largely all that was going on in them is that we had the parameter names and the parameter values. We didn't try to do any user interface sort of thing or spot where the designer specified things that they wanted other than directly manipulating the parameter values. In this image, which is figure 6.13, you can see that we have a red bar in column I. Everything to the left of that bar is a user input section. It's not read as code by SolidWorks or anyone else. This is where the designer types in the stuff that they want. And you need to follow this approach and this layout. And I'm going to tell you right now why. It's that your design tables are machine graded. We will open them up with a computer code. It will look for these columns. It will look for integers like 4 and 4 and 3 and 6. And these will represent lengths and widths. And it will also be looking for binary values that represent whether it is a tile or a plate or a brick. So you need to make sure you understand what that means. That means ones and zeros only. Okay, and then it will also be looking for some RGB colors. An RGB specification, which is a number from 0 to 255. And that's what you see in this green area of this design table. Okay, so what's going to happen with this then? Clearly, you put in the length of the Lego brick in terms of number of studs and the width of the Lego brick in number of studs. And then somewhere in the body of the design table where all the parameter values are specified, you need to have an equation. And that equation is going to calculate what the length of the Lego brick needs to be based on the common specification of a Lego brick, which is the number of studs in one direction and the number of studs in another direction. You're going to have to work out that math, and you're going to have to work out how to do that in the design table. Now, to do it, you're going to need to know a little bit about Excel logic. And There are basically two things that you're going to need to do, and the guidebook gives you a little bit of help with this, and if it does not give you enough help, you need to go just straight into Google and type in SolidWorks if-then statement, SolidWorks equation, SolidWorks formula, stuff like that. I'll just give you a couple of quick tips right now, which is that anytime you're using Excel and you want a cell to be an executed formula, you start that cell with an equal sign. And then you can just do the math that needs to be done. 4 times 22.1, and then, I don't know, what do you get with that? So 88.4. I don't even remember what numbers I said a second ago, but that's what would be calculated in that cell. And you can make that calculation be the way a parameter value is specified. And that's what you need to do in this advanced design table. The other thing that you need to do in the advanced design table relative to Excel logic is you're going to need to know how to do some if-then statements. If-then statements are going to be what allows you to say whether a brick is whether a Lego part is a brick or a plate or a tile. What's going to happen is that your design table is going to read the green area of this figure, and it's going to look to see for ones and zeros whether it's a brick or a plate or a tile or whatever. And then it's going to have to execute the right kind of commands for that to happen. And so you're going to need to know that piece. If you know those two pieces, you'll know enough Excel logic to move forward well in the process. Okay, let's go on to our next slide here. In the design tables that you will create 2 design tables. One will be for all of the 2x and largers. Okay. And I'm seeing right now that I actually have an error in here, which is that I have 2 1x bricks in this table that should be in the 1x table. Okay, and then you will have all of the 2x2 or larger bricks, plates, and tiles in another design table. It turns out that this is just a little bit easier and will take less time for you to treat these as 2 separate design tables than to try to handle it all in one design table, which is definitely possible, but it requires a greater amount of understanding of Excel logic, which I don't expect you to have now beyond the simple if-then statements. So I recommend that you do the following. You make the 2x4 Lego brick model with a design table in mind on how you're going to do it so that you can create all possible 2x2 or larger bricks, plates, and tiles. Once you have that working so that you can create all the parts shown in this image under the design table that's on the parts that are described on the bottom half of this slide, then what I recommend that you do is you just copy that file and you create, maybe you don't copy that file. Maybe what you need to do is you actually just need to think about how the 1x brick would be designed so that it can create all of the 1x options. And I believe your strategy will be a little bit different for making the 1x's than for making the 2x2s or larger. So I would do the brick portion first where you have the 2x4s and bigger, okay? And then I would go and do the process again for the 1x's. All right, you'll actually find, this is how it goes with all things like this, you will find that it will take a significant amount of brain power to do the 2x2 or larger. And then even though the work is exactly the same for the 1x, you'll find it takes a lot less brain power because you've already you've learned what needs to be done by doing the 2x. As you can see with this giant orange arrow, there are some of these that are 2x2s or larger that should be in the other table. And there's also some 1x's that are in the 2x2 or larger table that should be in the higher table. This is just a mistake in my compiling of this image in terms of how I want to describe it right now. So understand there's those 2 tables, 1x, and the other table, 2x2 or larger. Okay, now I want to talk a little bit about how you would actually go about doing this. I have produced for you a video that shows how I used some advanced logic in Excel and to do an advanced design table for these things that are called 3x3, 2, 1 blocks, or sometimes called 1, 2, 3 blocks, which are used in machining and used in other design settings. In fact, I was just watching a video the other day from Adam Savage Tested. I like watching him. I don't watch all of his stuff because sometimes they're super long, but I do watch some of his stuff and have a good time. And you can see on his table, right near his hands, there is a 1, 2, 3 block that he's using as a paperweight for this thing that he's working on. Okay, so check out that example if you're kind of unsure how to even get going or want to see something that's similar to a Lego brick done in a design table. Okay, time for us to go on to part 4. We need to talk about probably one of the most critical parts of this project, which is choosing a structure. This is a big decision and one that you should not take lightly. And here are my tips for how you should do it. Number 1, choose a building that is interesting so that you aren't making simply a box. Okay, you need to choose a building that has some interesting elements to it. People aren't going to want to buy a Lego architecture kit that's basically a box. Okay, all right. Number 2, identify for that building 2 or 3 or 4 of its most defining characteristics. Then you're going to have to make sure that those defining characteristics are in your Lego structure. All right, then you can also extract out, number 3 here, extract out the proportions of the building. The proportions of the building are really important for getting people's brains to think that you modeled the structure well. So how are you going to do that? Number 1, if you're near the building, you can make some rough estimates by walking around it and kind of measuring the length of your stride and then getting some lengths, widths, and stuff like that. You can also take a photograph of the structure and then get one known dimension off of that. It might be the height of a door, it might be the length of a window that maybe you could measure, or if it's a building that's in another country, you could basically look at the height of a person who's in the image, and from that extract out the length, the width, the height, that would be needed to understand the proportions of the building. Getting the proportions right is really, really important. In fact, I'm going to show you right now a few examples on campus relative to this so that you can get what I'm talking about. We'll do that little field trip in just a minute. All right. Once you've extracted out the proportions of the building, you need to explore how the basic sizes would work in Lego. And one of the ways that I like to do that is that I generally think about the roof, because the roof is like a giant deal. If the roof is super complex, you're going to find that the Lego parts don't exist for those things. And so if you have a really complex roof, I would suggest choosing another building. And then the other thing I do, and this is number 6, is to consider the smallest features. What I mean is if you can figure out the features in the building that are defining characteristics that appear to be kind of like the smallest, then you're going to look at your smallest Lego bricks and know that that is going to define the entire size of the structure. So, for example, I'm looking right here at the Lincoln Memorial. And in the Lincoln Memorial, one of the defining features, of course, is all of these pillars. All right, so if I'm thinking about all those pillars, I've got to say, okay, what is the smallest way I can make those pillars in my Lego architecture structure? And so this one is a rod, and the rod has a certain size, and the rod can only be centered stud by stud by stud by stud. And what this means is that once I have figured out that detail, I essentially know exactly how wide and long the Lego structure needs to be in order to capture the proportions correctly. And if I do that, if we work out the proportions and then the minimum feature and then work it out on a piece of paper, we'll know whether we can meet the constraints of the project, which is to fit on a particular size base. All right, and then the last one here that I want to give you on tips for choosing the building and moving forward with your stuff here is that you want to eliminate details that you won't be able to model. You need to look at your building and say, I can't model that, I can't model that, I can't model that. And if I don't model those things, will I still have a building that will be representative and a good representation of the product that I'm trying to model. All right, so let me give you sort of a little tip on how that goes, or not tip, but maybe like an example of how that goes. Here is a building I thought about last year as I started to work through this project. And frankly, I like to work on all these projects as well. I don't like to ask you to do anything that I haven't done myself. And so I tried this out, and I want to show you how it goes, and you need to be okay with how it goes. Here's how it goes. I said to myself, here's an interesting building. It is the Assembly Hall on Temple Square in Salt Lake City. What a beautiful building. I thought maybe I could do that. And so what I did is I found myself an image of this building that was kind of as straight on as I could find. And then what I did was I started to look at the features on this building. Okay, so the defining characteristics. The defining characteristics of this building are the spires, the center thing that's at the top. I don't know what that's called. The steep pitched roof. Okay, and then these rectangular windows. Those are all sort of defining characteristics. Also, another defining characteristic here is these sort of protruding columns that are, there's 1, 2, 3, 4, 5, 6, 7 of them across this building. And also, while you're looking at this building, it's interesting to note that it's not symmetrical from this view. The left side has only 2 windows, the right side has 3 sets of windows. So these are things I'm thinking about as I'm looking at this building, thinking about how it could be done. And so what I do now is I say to myself, let's get out a piece of paper and start doing a little bit of sketching. And here's what I do. I kind of write out what are the defining characteristics. You can see that the spire, the center tower, the steep roof, the roof valleys. These were things that seemed to be important. Then I went to drawing out kind of this side view, which you see here, which is very similar to the actual image that I showed you a minute ago with the different number of windows on the left side versus the right side. And I started to work out what would be sort of the minimum way of capturing some of these features. And what I thought to myself was, I'm going to go back a slide here for a second. I have these protruding columns that are kind of coming out. If I make that 1 Lego brick wide, how many bricks wide would this entire building have to be? And that's what I have worked out right here. I got 1 in this area, and then I decided that I would have to, compress this and stick 1 in this area, then 1 for the next column, and 1 for the next window area, and 1 for the next column, which would give me 5 Lego bricks wide. And then in the door area, I tried to work out, got 1 on the side of the door, maybe 2 in the door area, 1 on the door other side. And then I did the same thing for the larger side and found that I could make this in 16 Lego bricks wide. So far things are looking pretty good, right? Once I knew that number, I could look at the proportions of the building. When I looked at the proportions of the building, it meant that its width needed to be 11 or 12. 11 or 12 to get the right proportions. And then, okay, what do we do now? Okay, what am I looking at? Okay, yeah, so then I'm saying to myself, let's work on the height. How would I work out the height of this to get the proportions to be just right? And so I'm kind of scratching out some things. I'm figuring out how big would the smallest door be. Looks like I've chosen the door to be 1 unit wide. And then be aware the Lego width is not the same as the Lego height. So if I have one Lego width, then I have a different height. And here I'm specifying, I'm thinking about that as being 1.5 Lego bricks high. And so I've kind of worked out how I might do this whole thing. And so far in my process, things are looking pretty good. And frankly, at this point in the process, I've probably spent about 20 minutes on the project. Quickly chose a building, quickly found some images, quickly extracted out some of the key features, quickly sketched out some stuff, and started to work out some numbers. 20 to 30 minutes, I'd say, was on this. Okay, and then I got to what turned out to be the showstopper for this particular thing. I said, okay, I started at the bottom, I got my proportions, I've worked up, let me look at my roof now. which is why I have a suggestion that you look at the roof first, because the roof was the showstopper on this one. I looked at the images and found that the assembly hall has roughly a 65-degree pitch. That's great. It turns out that Lego also has a 65-degree pitch. It's the same one that basically we see on the Louvre model. But what the Lego bricks don't have is a concave portion of those steep bricks. So there are convex portions of those bricks, and there are concave portions of those bricks, or versions of roof tiles. And Lego does not have concave versions of the steep roof tiles. So I thought, well, I could go and like use some hinges and make some plates come down at certain angles. I thought that's going to compromise the way that this was going to look, and I don't want to do that. So I went on to thinking about another building, having spent about a half hour in total. I actually don't think it was much more than that. About a half hour exploring this idea, looking to see what would work, and then jettisoning it. Okay, well, I jettisoned it for another project. All right, so now I'm not going to show you any more images on this, but then I went on and looked at, well, maybe I would do the Provo Convention Center downtown, that's on Center Street. I thought that's kind of an interesting building. It had some interesting looks. It has flat roof. That helps me a lot. And I wasn't satisfied with how some of the details were working out on that one. So I had spent at that point maybe about 15 minutes on that building before I converged on working on a building that exists in the middle of the Amazon where I served my mission, and turned out to make a fairly interesting model of that, which worked out really well in the Lego thing. So what does this tell us? This is just a reminder of iteration. Okay, the design process requires iteration. First we understand, then we explore, and while we explore one thing and we see whether it works. Then if it doesn't work, we explore another thing and we see if that works. And then after a couple of rounds, we have started to understand what will work and what won't work. And this is a normal part of the design process. So that's why you need to get going on this right away, so that you have time to have an hour and a half of messing around with buildings before you really get down to the one that's going to be just right for you. Let's do a field trip and go look at some buildings. One more thing. Let's go. Cool car. All right, so this is the Kimball Tower. The Kimball Tower has something like 12 or 13 floors in it. The reason why I'm bringing up this building right now is that I want you to know that you need to adjust your buildings a little bit in order to get the proportions to be right. So for example, I've seen enough students try this building over the years that it's pretty clear that if you do it with the exact number of stories, say 12 or 13 or whatever it is, the proportions are wrong. You actually have to go for a lower number of stories. And it's not like people sit there and count the stories on the Lego model, so the proportions are more important than the absolute correctness of it. All right, take a look at this building. And I want you to actually see right there, right in that area, which I'll use they have cut the Lego bricks. Not allowed to do that. No cutting, no making special things, no having bricks overlapping with each other. Yeah, so the same thing's going on the inside of that roof. All right, that's the end of our tour. Going back up into the office. Take care of the rest of the business. Okay, here's the situation. Now, the building that you need to create does not need to be 100% precise. In fact, there's no way to do that. You're going to have to make some sort of representation of that building. And so when we looked at the Kimball Tower just a minute ago, that maybe you can see outside there, just want to point that out, that you're going to have to make the adjustments that favor the notion of proportion and that also favor recognizability. That when someone sees this thing, they're going to know exactly what your building is. All right, back to business. Another thing that I just want to point out, I showed this slide in class the other day, and just want to point out that everything here on this top row is just too much. It's too complicated. Don't do it. Okay. Everything on the second row is closer, and it could work for you. There's, I think that those could work. That would be a great scope. But the ones on the bottom, I think, are even better. And I just want to point out why I think they're better. Number one, the ones on the bottom have a significant amount of, maybe with the exception of the one on the far left, there's a significant amount of patterning. And patterning is good here because it means, in essence, less work. You're designing one sort of little module of the building and then copying it up many, many times. And that's one of the reasons why these buildings are good to do. These buildings are also pretty great to do because they're not attempting to deal with the roof angles. And frankly, you can do roof angles well. You just have to be really careful with about it. There's a lot of thought that has to go into the roof. These ones have a nice flat roof. I like that. I also like that, with the exception of the second one from the left, none of these are showing the studs, which is one of the characteristics of the Lego architecture structure, is that the studs are largely all hidden by tiles that are put over them. That gives a nice, clean, beautiful look. All right, and then the other reason why these ones on the bottom are pretty good is because they have captured the essence of the building without trying to get all of the details of the building, but they've captured the essence. So I guess what I mean by this is that not a one of these has a door handle or a mailbox in front of it or anything else like that. It's capturing the interesting overall shape of the building. So scope your project well. It's so important to do that. All right, next part we want to talk about here is the last part we want to talk about today, which is just to remind you and or make you aware right now that there is a PDF design package that is turned in at the end of this project. And that package has a lot of things in it. As you can see here, which I have an example of the Bessie clamp assembly design package, which you can basically follow the same kind of thing. I didn't want to create one for a Lego structure itself, because then I don't want you to copy like directly, but you can look at the form of this one and follow it, which is that we have a front cover, and that front cover has a small table of contents. It has your name, it has a rendering on there. Then on our next page, which I'm moving now to the right, we have an image of the actual product and then the rendered product. And then in the middle of this one, there is a sketch, but you don't have to put a sketch of your building in there in this composite. In fact, I prefer not to see it. What I want to see is the actual building right next to the actual rendering in the same orientation, so that I can compare how well you've captured proportion and how well you've captured detail appropriately in the model. Okay, then we have a full page render of the product with white text that simply says the name of the product, which in your case will be the name of a building, and then the number of pieces that would be in there. This is similar to a Lego architecture box cover, but I don't want you to create a Lego architecture box cover with the words Lego or architecture or anything like that. I just want to have a simple black background or near black background and white text describing what it is with the number of pieces. Then you're going to have some CAD strategy that's in there for some of the parts, I guess in this case for the Lego brick. And then you're going to have your brick part engineering drawings, which is what we kind of see here in the center at the bottom. And then you're going to have the engineering drawings for the assembly. And those are all going to be compiled into one PDF and turned in. And that is a large part of what's going to be graded in the project. Okay, that represents everything that I wanted to talk about today. As I said, our goal here was to help you avoid some problems. to clarify what needed to be done and to help you avoid those pitfalls that are going to make it harder for you. If I just have one major tip for you that I've already said before, but I'm going to say again right now, you have to have good time management. You have to crunch. At this point, you should have finished the Lego sketch. You should have scanned it. You should have gotten it ready for submission. You should have made your Lego strategy with thinking about the design table in mind, sketched it out, scanned it, get it all ready for submission. If you have not done that, you're behind and you now need to put in more time. Beginning here on this day that you're watching this lecture, you need to be actually starting the design tables today. And then give yourself just 2 or maybe 3 days to finish all of those design tables so that by the time you start the beginning of next week, you have an entire week to work on the assembly. Be aware that the entire project is due on a Monday this semester, not a Tuesday like all of the other things that you've been working on. So be very aware of that, pay attention to it, and please ask for help, guidance, and approval on any tiny deviations that you want to make. I will say, though, that there are some deviations that I will not allow. You must not go larger than the largest available size for the plate that you're going to build on. You must have a black border around it. You must use only the parts that are made available to you. You can't use any other parts that you find on the internet or anything like that. And then you can use your design table for stuff. Okay. Also, relative to color, you want to be simple in the color. Only use the colors that I have said are available to you, and use the colors largely as accents to an otherwise white building that is consistent with the Lego architecture structure. Okay, thanks everyone. I wish you the best on this. Good luck.